Learn how to use Stable Diffusion to create art and images in this full course. You will learn how to train your own model, how to use ControlNet, and how to use Stable Diffusion's API endpoint. This course focuses on teaching you how to use Stable Diffusion as a tool instead of going into the technical details. It's a perfect starting place for beginners. Lin Zheng developed this course. She is a software engineer at Salesforce and a freeCodeCamp team member. Let's get started.
Hey everyone, I'm Lin. I'm a software engineer and a hobbyist game developer. And today I'm bringing you a new hands-on coding tutorial. In today's video, we're gonna generate art using an AI tool called Stable Diffusion. If you look up the definition of Stable Diffusion, it is a deep learning text-to-image model released in 2022 based on diffusion techniques. In today's video, we're gonna focus on teaching you how to use Stable Diffusion as a tool instead of going into the technical details. To understand some big terms like variational autoencoders or embeddings or diffusion techniques, you will have to have some machine learning background and also do some research on your own. There is some hardware requirement for this course. You will need to have access to some form of GPU, either local or AWS or some other cloud-hosted ones, to try the course material, because we will be hosting our own instance of Stable Diffusion. It's very unfortunate this will not work for the free GPU environment that Google Colab provides, because Google Colab bans Stable Diffusion from running in their notebooks. Don't worry if you really don't have access to any GPU power. It is still possible for you to try out some web-hosted Stable Diffusion instances. I will include an extra part at the end of this video to show you how you can access these cloud-hosted environments. So that said, let's take a look at the topics we're going to cover today. The first one will be how to use Stable Diffusion, how to set it up locally. The second, how to train your own model for a specific character or art style. We call these LoRa models. Third, how to use ControlNet, a popular Stable Diffusion plugin. And last but not least, how to use Stable Diffusion's API endpoint. At the end of the course, you should have no problem generating images that look like these. Pretty impressive, huh? Alright, I know you're excited, but before we get started, a disclaimer. We respect the work of artists and acknowledge that AI-generated art using Stable Diffusion is a tool that could be used to enhance creativity, but it does not replace the value of human creativity. Alright, and now we are ready to get started. Let's start by installing Stable Diffusion on your local. We're gonna go to this GitHub repository and install them based on the instructions. I'm gonna be installing on a Linux machine. The installation process may take a while, so be patient. Alright, and now everything has been installed. Let's open the directory that we just installed and inspect the contents. We can see that there is a subdirectory for the models. The instructions under Models Stable Diffusion says to put Stable Diffusion checkpoint models here. So let's go and download some models. The website that we're going to be using is Civet AI. Civet AI is a model hosting site, and we can see there are lots of models uploaded by different users. One of the models that I like to use is called Counterfeit. It generates anime-like images. When we open the model page, we can see some sample images generated by the model. And if we take a look at the files, these are the uploaded models. It looks like the maintainer of this model regularly updates the versions, so we can go to their links to see the updated versions. We see a bunch of files ending in .safe tensors, and these will be the models that we're gonna use. We also see a .vae.pt. This is a variational autoencoder model that will make our images look better, more saturated and clearer. We're gonna download the models and put the checkpoint models in models/stable diffusion and the VAE in models/VAEs. If the VAE folder doesn't exist, just create a VAE folder. Once we have downloaded our checkpoint and VAE models, we're almost ready to launch the web UI. We can customize some settings in webui-user.shell. When you open this file, the export command line args should be an empty string. For my command line arguments, I have configured it to share. This means that when I launch the web UI, besides localhost, it will also expose a public accessible URL. This way, my friends can access my locally hosted web UI via this public URL. Here's a part that I didn't capture in the video. For the web UI to use the VAE by default, you have to set the VAE path in webui-user.shell. Here is my webui-user.shell. It has lots of customizations. Now it's finally time to start the web UI using webui.shell. If you're a Windows user, you will run webui.bat. Starting the web UI is gonna take some time, so I will speed up the video. From the log lines, you can see that our VAE has been loaded. And we have both a localhost URL and a public URL. Let's try out the public URL. So this is what the web user interface looks like. We can see a big text box here for entering prompts to generate an image. Alright, let's start typing something. I'm gonna ask for a girl with short brown hair and green eyes and with a simple background. Let's hit the big generate button, and it's gonna take a few minutes. I'm gonna speed up the video for you. Alright, it looks like we got our girl with short brown hair and green eyes on a simple background. Alright, so our text prompt in the form of a long string worked. It is also possible to use keywords or tags. We're gonna look at this website that has some reference tags. For example, you can see like girl, long hair, short hair, skirt. Most of the checkpoint models we're using for Stable Diffusion are indeed trained on these tags, so the models will have no problem parsing those keywords. Let's rewrite our prompt using those keywords. And then after rewriting our prompt, we're gonna look at some of the parameters. You can see when you hover over the parameters, there's some explanation text. We're gonna increase the batch size so that we get multiple images from one generation, and turn on restore phase. You can learn about these parameters by hovering over them and reading about them yourself. And indeed, we got some girls with brown hair, green eyes, round glasses on a very simple background. I actually want Stable Diffusion to help generate some images of Lydia, our protagonist from Learn to Code RPG, who has brown hair, green eyes, round glasses, and also braids her hair between the back of her head. So we're gonna add braided hair to see if the AI will pick it up. If you're like me, you might notice that the background is a little bit too green, and we can adjust that. We just need to put in a negative prompt for a green background, and we will see different color backgrounds. The good news is that the backgrounds are no longer green. However, the braided hair isn't exactly in the direction that we want it to be. So I guess we should adjust that in the prompt. I feel like it's also a good time to experiment with a different sampling method. Different samplers can produce pretty different art styles, and you can see some comparison images if you do a Google search. I will also try to link to some in my article. Looks like the first and second picture do look like Lydia's hairstyle. Alright, we're just gonna keep playing with it and add some different prompts. Alright, so we asked the AI to show our hands. However, the hands are pretty deformed, and here we're gonna try to fix them by using embeddings. We again go to counterfeit model page, and we see easy negative. This is one of the textual inversion embeddings that we can use. So the first row is with easy negative, and the second row is without. Looks like easy negative does enhance the image quality and make better hands. Alright, we're gonna grab those easy negative.safe tensors and put it in our embeddings directory. Alright, going back to our web UI, we're gonna add easy negative to the negative prompts. Click on this button that shows a portrait, and under textual inversion we have easy negative. Clicking on it will bring it into the negative prompts. Alright, let's do some more generations. So what do you think? Do you think the images look better with easy negative? I think so. Alright, looks like we got the basics of text to image. Now it's time to try out image to image. Let's save this image for our use. Go to the image to image tab and upload our image here. Suppose we want a similar pose, but instead of a brown hair girl, we want a pink hair girl. Image to image also have batch size and the restore faces and all the other settings we've seen in text to image. Let's hit generate. We can see that the generated images all have similar poses to our original image, but the hair color has changed to pink. Let's add our easy negative embeddings and try some other prompts. For example, this time instead of a white background, I would like to add some detailed backgrounds. And hit generate. Alright, similar poses, no glasses, and with some books in the background. For other image-to-image options besides uploading a picture, you can also do Sketch or in Paint to repair or restore by repainting obliterated areas. This is pretty much it for the basic usage of Stable Diffusion. Next, we're going to cover how to train a model for a specific character or specific art style. These models are also known as LoRA models. The internet definition for LoRA is low-rank adaptation. It is a new technique for fine-tuning deep learning models that works by reducing the number of trainable parameters and enables efficient task switching. So essentially, for Stable Diffusion, we are patching the checkpoint models so that the generated images will look more like our character or art style. For this part of the tutorial, we won't need to use your local. We will be doing everything in Google Colab. We're going to use this amazing tutorial on Civet AI to train our LoRA. It's worth noting that since Google Colab is an online collaborative service, and the maintainer might need to modify or update some of the code inside the notebook, it will be perfectly normal if your notebook doesn't look like mine or you run into some errors I didn't run into during recording this tutorial. In that case, reaching out to this maintainer on the Civet AI post might help. Cool, time to take a look at the dataset requirements. For you to be able to train your LoRA, you will need anything between 20 up to 1,000 images of your desired character or art style. Also, your images should have some diversity. If all of them are close-up shots of the face, your model will have a hard time generating the whole body. Feel free to read the tutorial thoroughly in your free time, but I'm gonna just jump straight to copying the notebook. Here is the notebook that we just copied. I'm gonna put down Lydia as the project name because I want to be able to generate a model specifically for Learn to Code RPG's protagonist Lydia. And when we run this cell, it's gonna prompt us to connect to our Google Drive so that it can read our training images. And in this cell, you can decide whether to grab images from the internet or to upload them to your Google Drive so you can read them in from your Google Colab. Here in your Google Drive, you can see that the first step of the Google Colab notebook created a LoRA folder, and inside it, there is your project, Lydia, and we're gonna upload our training images to this dataset folder. I have 13 or 14 images generated by AI, and when I was creating the tutorial, Quincy asked whether I think there will be an inbreeding effect if the AI is consuming images generated also by AI, but I think we'll be okay. I'm just gonna give it a few minutes for the upload to be complete, and then we're ready to curate our dataset. Here is a cell titled Curate Your Images. It will help you eliminate duplicates from your training set. However, I know that my training set doesn't have any duplicates, so I will skip this part. Alright, this next cell will use some AI tools to help us tag our images. In other words, to generate those keywords we've been using as the text prompt. So like for those Lydia's images, we might expect tags like brown hair, short hair, green eyes, one girl solo, face focused, and so on. Once this AI auto tagging is complete, the next step will help us curate our tags. This global activation tag will help identify our LoRa model when we are using a base Stable Diffusion model. When we put in the activation tag in the text prompt, the Stable Diffusion base model will know to generate characters or art style that's specific to our LoRa. Let's wait for these cells to finish and take a look at the results. Here are the top 50 tags from our training set. So we see one girl solo, brown hair, green eyes, all those tags that we expect. Now we run this curate your tag cell to add this global activation tag to our many tags. We are basically ready to go. When we look at the extras, we can analyze the tags. And if we look at it, we should be able to see our global activation tags as well as the other tags we identified earlier. Just like for the last notebook, in the project name, we're going to put in Lydia. And we can inspect some of the training parameters. For example, you get a base training model, but you can also use your own if you don't like the default. And there's activation tag, which is the global activation tag that we put in earlier. But before we can run this notebook, we need to close the other notebook. And not just close, we need to delete the runtime too. This is because Google Colab wouldn't let you run more than one runtime if you are using the free version. So we go back to our dataset maker notebook, interrupt any execution that might still be happening, and manage runtime, and delete this one. Now we can return to our training notebook. There is one additional parameters that we need to think about, which is the training steps. This will determine how long you will train your model for. Let's look at some guidelines from the original Civet AI post. The guide is saying that too few steps will undercook the LoRa and make it useless, and too many will overcook it and distort your images. So we're gonna find a balance between these. In this notebook, it also says that your image will repeat this number of times during training. I recommend your images multiplied by their repeat is between 200 and 400. So since we have like 13 images, we're gonna slightly increase the number of repeats. And instead of saving every epoch, we're gonna save every 2 epochs. Let's leave all the other parameters as default and start running the training. Training might take some time depending on your configurations. My model took like 20-something minutes to train, and I'll speed up the process just for you. Alright, now we see step 100% done. Our model is fully trained. Inside Lydia output, we see multiple models, ending in safe tensors. The number indicates the number of epochs the model has been training for. Now comes the fun part of evaluating our model by generating some images. Let me take some time to explain the customizations I put into WebUI user.show. --share, as we mentioned before, generates a public URL. Xformers, according to the docs, will increase the performance on certain hardware. Theme dark, because I prefer dark theme to the light theme. And the VAE path, and also no half VAE, is to prevent some floating point errors. Alright, now we launch the WebUI and wait for it to give us the public URL. Now the WebUI is all ready. As usual, we put in our easy negative embeddings. Then let's first try the LoRa that has been trained for 8 epochs. Alright, the results are looking pretty decent. Without any other prompts, the LoRa has captured Lydia's some character traits, for example, short brown hair and green eyes. However, we can do better. As you may remember from our training, we put in an activation keyword. And now, let's put in the activation keyword to see if that helps guide the LoRa model even better. Alright, now we got the results. You might notice that there are a lot of half-body images instead of the more diverse full-body ones we saw with the previous prompt before it added the FCC Lydia keyword. This might be because our training set has a lot of half-body images, and that's what this model selected for. If you are doing your own character, remember to have some diversity in your training set poses. Alright, now let's try the model that has been trained for 10 epochs to see if there is any major difference. The results are not significantly different, but do notice that in one of the images we get some hint of some glosses without us having to enter the glosses as part of the tags. Now let's try adding a lot more tags and being more specific with the model to see if it generates more detailed images. Alright, now the results have a lot more resemblance to Lydia. Well, in Learn to Code RPG, Lydia worked at a cafe as a barista while she was also learning how to code on the side. So let's change up the background to see if we can make Lydia a barista. So cafe and barista outfit and the apron. Alright, looks like we might be missing the glasses, so let's try again. We can also change our base model so that we get a completely different base art style. I have another one, and we can give that one a try too. Alright, now the model is fully loaded. Let's click the Generate button. Well, this OpenEG model is supposed to mimic the style of an EG Journey, which is used by Midjourney. So it looks like it has a more vibrant art style, which people might enjoy better. Feel free to experiment with different base models and see which one you like the most. Next, we can try adding more LoRa's and generate more complex images. Navigate back to the Civic website that we have open, and we can see that besides those checkpoint models, there are some LoRa models. And if we click on those sample images, they have the generation data there. They have the text prompt, negative prompts, and sampler, number of steps, etc. These generation data are a really good reference, and especially if you copy the seed too, you should be able to get an image very similar to the sample image. It's no guarantee that they're going to be exactly the same, but they should be very similar. Alright, let's find some LoRa to use with the LoRa models that we have already trained. For example, I like this LoRa model which is trained on black and white manga images, and they should give you images a manga-like style if you copy their trigger words. Let's download it and put it in our model's LoRa folder. Now on my web UI, if I refresh, I should be able to see the anime line art manga-like model. And let's add it to our prompt. We need to add the trigger words too, which are line art and monochrome. Alright, we can see that now our images look like black and white manga style. That's pretty cool. In the next part, we're gonna cover how to use ControlNet to gain more fine-grained control of your image generation. Here is the GitHub page of the ControlNet Web UI plugin. ControlNet actually gives you fine-tuning power over your images. You can fill in your line art with AI-generated colors. You could just scribble and let AI fill in the rest for you, or you could even control the pose of characters in your picture. Let's scroll through this page and get to the installation parts. Follow the installation steps, and if you run into any security warnings, you might need to add Enable Insecure Extension Access to your webuser.shell and then restart Web UI and try the installation. After installation, just follow these steps and download the models you need and put them in the correct folder. Once you've done these, it's time to go back to the Web UI and try out the ControlNet plugin. Alright, so when you expand it, the ControlNet plugin looks like this. There's an area for you to drag and drop images, and there are several parameters that you could set. So I'm gonna turn on low VRAM and also just enable the ControlNet plugin. Pixel perfect, and I have two models. I have a scribble and a line art. Let's redo our text prompt. Both the text prompt and the ControlNet parameter setting will affect how the images turn out. Cool. So I'm gonna connect to my tablet and just draw something really random on this canvas and see what we can generate from there. Well, don't play too much bets on my drawing skill. I'm just gonna roughly draw a person. It's really hard to use the provided pen tool, so yeah, this is the head, those are the eyes, and the body. Well, I hope ControlNet and the amazing AI is gonna help me fix my drawing. Well, I'm being totally unnecessary here, but I'm gonna draw some ribbons. And they, of course, don't even look like ribbons. Well, we could see that the generated images basically followed all the line art work I did and filled in some pretty amazing looking colors. It's actually pretty impressive, and they even got the ribbons right. Well, that was for the scribble model. Now let's use some real line art and try the line art model as well. So I do have some promotional artwork I did for Learn to Code RPG, so let's try it. Now let's configure our text prompt. We'll do the regular easy negative for the negative prompts. And then pick a sampling method. And we want the setting to be a cafe. Want the lighting to be softer and detailed. You might have noticed that we actually didn't put in any request for people to be in the image. We'll see whether the generated image actually has people in it or not. And this time we do the line art model. So because we didn't ask for any people to be in the artwork, we are only getting images of the cafe background, looks like. I guess we need to explicitly put in 2 girls in the prompt. And it looks like this time we are getting girls in the images. Looks like AI has filled in colors for our line art. So that was the result of the line art model. The colors are a little bit weird, so let's give the AI some more freedom and use the scribble one instead. Well, now the AI has full freedom to imagine the faces of the 2 girls, and looks like the results are pretty decent. The images are in square, but our line art original picture is in a square. So let's fix up the aspect ratio. Again, with the Scribble model, let's generate some more images. So yeah, on the left is my original line art, and looks like the AI have generated something that looks pretty vibrant colored. These actually look pretty good. I'm very impressed. Alright, besides ControlNet, there are some other really powerful plugins or extensions maintained by other open source contributors. I'm gonna show you where to find those. So on the wiki page of the Stable Diffusion UI Git repository, we see a page for extensions. For example, this one looks like it works with ControlNet. And this VRAM estimator will allow you to increase dimensions of your image and batch size until you run out of memory. So you can maximize your VRAM usage. This one will allow you to draw some poses. This one says it will target an area to selectively enhance details. This one I've seen a lot of people use to generate videos. And it works with the ControlNet extension too. This one will help you fine-tune where your LoRa is acting on in the image. This theme seems to be showing you a custom thumbnail view of your LoRa model. This one's for localization. This one is for editing pose. I'm just scrolling through, it's a long list, just to see what kind of cool effects we can have. This one converts your images into pixel art style. Looks pretty cool. This one uses transformer models to generate text prompts for you. Another pixel art, and other effects too. Another prompt generator. This one saves intermediate images while the AI is trying hard to generate them. There's even this one that will automatically remove backgrounds and leave only the central figures. Yeah, so there are lots and lots of those extensions out there. There's a lot for you to explore. We can't possibly cover everything in a single course. And people also create their own plugins and extensions as they see their need arise. Moving on, let's talk about generating images using the Stable Diffusion API. There is this API doc page on the Stable Diffusion repository website. And to enable the API, we need to turn on --API in our web UI user.shell. We can see that there are several endpoints. For example, the text-to-image API endpoint, image-to-image API endpoint. And when we scroll down, we see sample payload. We just put in our prompt and number of steps and other parameters in the payload, and it will be exactly the same as if we were using the web UI itself. So the idea is that we send the parameter payload to the web UI API endpoint using a post method, and then we will retrieve some bytes that we can decode into our image. Below, the developers have provided us with some sample Python code snippet that we can use to query the endpoint and get our images and save it as the output.png. Alright, let's grab this code snippet and run it locally. Alright, for now, I'm just going to copy paste it and run it directly, and I will talk through the code in a little bit once we see the output. Just know for now that our payload is a simple puppy dog. If we don't have some of the modules installed that we have to import, we need to install them using pip. And just run python 3 st.py and wait for it to finish. Well, looks like it has finished, and we have an output.png file, which is a puppy. Alright, let's try some different prompts. We can add negative prompts into the payload too. Run the file again and see what we are gonna get. Oh, that looks pretty futuristic and really cool. Of course, we could append our LAR model into it and see if we can get Lydia generated. Well, it's taking longer to run because we have increased the number of steps. And we have a picture of Lydia. The last 5 minutes of the video is like a bonus part. We're gonna use Postman, which is an app for us to test out API endpoints. We are gonna look at how the images is represented in the API response. And we will also take a deep dive into the Python code and walk through it line by line. This is the Postman app. We're going to put in our request URL there, which is the text-to-image endpoint, and we're going to use the post method. Make sure the body is JSON, raw. And click send. So we get this long string representing our images. And then in the response, we could see some other parameters that we don't need to pay too much attention to. I searched for some base 64 to image decoder online, and we'll see whether it works or not. Alright, remove the quotes. Remove the starting quote too. And here's our image. Now let's walk through this Python file line by line. So here we're doing a bunch of imports. We imported JSON, we imported requests for making a post request, and we imported base64 for decoding, and we imported some image libraries. And we set our URL to be the public instance that our web UI is running on. And we create our payload just like this. And then we post to our URL and the specific API endpoint, which is text to image, give it the payload, and then get a response, convert it to JSON. And remember the images field that we saw? That's our image string. So we decode it into an image. This part here is retrieving some metadata for the PNG. For example, what parameters are used to generate the PNG, etc. And finally, we save this image alongside with this PNG info. It's pretty straightforward. Feel free to play with the code on your own. You can also make API requests in other programming languages of your choice. Alright, as promised, in case you don't have access to a GPU, here are some ways you can run Stable Diffusion on some free online platforms. Of course, there's gonna be restrictions, like you won't have access to all the models you want, you won't be able to upload your custom model, and other people on the internet are also using this service, so you could be in the queue for a long time before your images are generated. Here we are on Hugging Face, and we will go to Spaces. And in the search bar, we type in Stable Diffusion. And let's sort by most number of likes. So looks like the most popular one is the one by Stability AI, which happened to be the original one. So this will be the best option. However, it shows that it is paused. So I don't think we'll be able to use it. Let's take a look at the other ones that we have access to. Of course, these online models might be limited in that it doesn't have the base model you want, it doesn't have the style that you want, but this is the best we can do if we don't have access to a local GPU. The faces are a little distorted, so maybe this base model isn't great for generating anime images, and that's one of its limitations. Looking through the list, we see some image-to-image, some in-painting, some photo-generic one. I think we'll be using the photo-generic one. Let's give it a shot. Now, this one looks like the Stable Diffusion standard web UI that we're used to. And we can see that it's currently live and running on an online GPU. They say the model is Proto-Gen. Which should be a photorealism model. Looks like they are restraining the number of images we can generate. But let's do it. And also we will have to wait in the queue. So yeah, if you don't like to wait, or if you really need to use your custom models, you should consider getting your own GPU. Alright, finally, after waiting for almost 5 minutes, I got my result back. It looks pretty good. And with that, we will conclude today's tutorial. I hope you enjoyed it, and I hope to see you in the next video.